Hi guys! So in continuation of our lecture about single effect evaporators, we are now going to do a mass and enthalpy balance dito sa ating evaporator. So in our previous video, nagawa na natin yung mass balance natin. So we are just going to have a short review dito sa ating video ngayon. No? And katulad ng sinabi ko sa previous video natin, mas magiging madali na yung ating analysis ng enthalpy balance dahil alam na natin kung paano natin ginagamit yung mass balance dito sa ating single effect evaporator. So let us just do katulad nung ginawa natin previously, no, sa ating mass balance. So here we have our feed entering sa ating evaporator. And we labeled our feed as F, okay? So our feed F is the mass flow rate of our diluted feed, no? So let me write that here. Our F is our mass flow rate of dilute feed in kilogram per hour. And then natutunan din natin that our vapor is leaving here. Okay, and then we label this as V. Okay, so our V is our mass flow rate of our vapor. Okay, and then our product here is our concentrated liquid here. So this is our thick liquor. And then we label this as L. Okay, so our L is the mass flow rate of our liquor. Alright, we also learned that our steam is entering our heat exchange coil right here. So this is our steam. And we label this as S. Okay, so we could write here our S as the mass flow rate of our steam. Okay, so we also learned that our condensate here is also equal to S because there is no mixing happening between the steam and our feed. There's just one thing that I would like you to take note, that our tubes and heating chest right here sa ating evaporator is what we call calandria. Okay? So we just have to take note of that. Okay, so continue natin yung ating mga component dito, no? If you're going to have a solute balance, kailangan nating makuha yung solid fraction or yung mass fraction ng ating solute. And we learned that sa ating previous video that sa ating feed, ang value or mass fraction ng ating solute dito will be XF. Okay, so our XF is the solid fraction in feed, or the mass fraction dito sa ating feed. And dito sa ating liquor, we have here XL. So our XL here is the solid fraction in the liquor. And since XF and XL are weight fraction or mass fraction, so this is a dimensionless number. Alright, so katulad ng ginawa natin, no, sa ating previous video, we're going to get our overall material balance. Okay, so lahat ng pumapasok sa ating unit, we have F plus S, and lahat ng lumalabas, we have vapor, liquor, and the condensate. Liquor plus vapor plus the condensate, which is also equal to S. So our value of S will be cancelled out. So ang matitira lang sa ating overall material balance will be F is equal to L plus V. Okay, so now we are going to do component balance. Okay, so we are going to do solid balance, no? Or yung balance ng ating solute. So we will have F times the weight fraction ng ating feed, and this will be equal to L, weight fraction ng ating liquor, plus V, and V, which is the weight fraction sa ating vapor. And we know that we do not have solid sa ating vapor, so this will be equal to 0. Okay, so our component balance here will be F XF, which is equal to L XL. Okay, so yan yung na-derive natin sa ating previous video, no? Now, there are things that I would like you to take note. Our steam entering dito sa ating calandria or sa ating heating element dito is usually a saturated steam. So, it will be entering at its saturation temperature. Okay? So, we will be writing that as TS. So, our TS is the saturation temperature, okay, of the steam. Now, dito naman sa loob nating evaporator, mini-maintain natin ang temperature nito, no? Yung nasa loob ng ating evaporator. And this is, let us say this is T1. Okay, so T1 is actually the boiling point inside the evaporator. Okay? Alright, so basically, na-label na natin yung mga kailangan natin. Now, we're going to proceed sa ating enthalpy balance. Okay, so let us write that here. We're going to do an enthalpy balance. Now, in order to get the enthalpy balance, we just need to get the heat on every streams na meron tayo dito. Okay, and we're going to do that by multiplying yung ating mass flow rate sa enthalpy in every stream. Okay, so let us say for our feed, we have here F multiplied to the enthalpy in our feed, which is HF. Okay? Now, for uniformity na mga gagamitin nating variables dito, let us take note na kapag ang enthalpy in-express natin in small letter h, this is the enthalpy in a solid or liquid phase. And kapag nasa vapor phase naman siya or nasa gaseous phase, we will be writing the enthalpy in capital H. Just for reference, no? Para ma-identify natin alin yung nasa vapor phase at alin naman yung nasa liquid or solid phase, no? So, we have here our enthalpy sa ating feed, which is HF. Okay? So, let me label that dito. So, we have HF, which is the enthalpy of the feed. And the unit is in kilojoules per kilogram. Okay? So, it's better, I think, identify muna natin yung mga enthalpy natin. Ano? So, dito sa ating steam, this is in vapor form or in gaseous form. No? So, our enthalpy will be capital H, and then our subscript will be S to denote that this is in our steam. Okay? So, therefore, our HS is the enthalpy of the steam. This is in kilojoules per kilogram. Okay? And take note that our steam here is saturated, no? So, therefore, itong ating enthalpy of the steam is measured at its saturation temperature. Okay? So, this is at its saturation temperature, no? Okay, so ito nga yun, yung in-indicate natin dito sa ating label. Okay, so next is our enthalpy dito sa ating vapor. Okay, so this is in gaseous phase, so this will be capital HV, no? So we have our HV, which is the enthalpy of saturated vapor. And kung ang ating steam is measured at its saturation temperature, well, our enthalpy of saturated vapor is measured dito sa temperature na mini-maintain natin dito sa ating evaporator, because that is the boiling point, okay, in our evaporator. So, this is temperature T1. Okay, so the unit is also kilojoule per kilogram. Okay, so again, yung T1 is the boiling point inside the evaporator, which is maintained by certain vacuum condition. No? So that is our HV. So next is yung enthalpy dito sa ating liquor, no? Sa ating thick liquor. So we have a liquid here, so this will be small h, and we will have a subscript of L. So our HL is the enthalpy of concentrated product stream. Then finally, dito sa ating condensate. So this is a saturated liquid na, no? So this is the enthalpy of condensate. So this is in liquid form. So this will be a small h, no? So our HS is the enthalpy of the condensate. Okay, so ang unit is also kilojoule per kilogram. Okay, so alam na natin yung mga enthalpy natin sa bawat stream natin. So we're going to apply that. So again, enthalpy balance. So ito yung heat sa ating feed. So now let's going to get is yung isa pang stream na pumapasok, which is yung steam. So this is the steam and multiply to its enthalpy, which is HS. And this is equal to L multiply to the enthalpy dito sa ating L, which is HL, plus in our vapor. Okay, our vapor is gas, so we will have capital H, HV, plus sa ating condensate, no, which is a liquid, so we have SHS. Okay, so since equal yung ating S dito, we can actually combine these two. So we will have FHF plus S times HS minus HS. And this is equal to LHL plus VHV. Okay? And one thing that we need to take note here is that the difference between the enthalpy of our steam and the enthalpy of our condensate is the latent heat of vaporization. Okay, so this is actually the latent heat, or the latent heat of condensation, I mean. Okay, so basically we can also write this as FHF plus S, then the latent heat of our steam, and this is equal to LHL plus VHV. Okay, so basically this is our enthalpy balance, no, sa ating single effect evaporator. Now this is not over yet, no, so let us identify itong ating enthalpy sa ating feed. Our HF here is actually equal to the CP in our feed times the temperature in our feed minus 0 degree Celsius. Now, what are these values? Itong ating CPF, this is the specific heat of the feed. Then, TF is the temperature of the feed. And why do we have 0 degrees Celsius here? This is our reference temperature para sa ating enthalpy. This is actually because we based our calculation for enthalpy with reference to 0 degrees Celsius. We have to take note that enthalpy is always relative rather than absolute value, no? So this is actually our reference temperature. Okay, so we have to take note of that para malaman natin kung saan natin kukunin itong ating mga enthalpy values dito. Now, sabi natin itong ating latent heat, okay, na nandito, is the difference between HS and HS dito. So, paano natin makukuha yan? Unahin natin yung HS, no? So, yung HS natin, okay, which is this one, means ito yung naandito sa ating steam, no? Yung pumapasok sa ating heating coils o sa heating tubes natin, no? So, our HS can be obtained from the steam table. And this is related sa saturation temperature and saturation pressure natin sa ating steam, no? So, ipapakita natin yan sa inyo kapag nag-solve na tayo ng problem, okay, involving enthalpy balance. Ngayon, yung HB natin, okay, itong ating vapor, okay, yung enthalpy sa ating vapor. So, it's the same, no? Makukuha din natin yan sa ating steam table. Okay, so this is also obtained from steam table. Now, if HS, okay, so yung enthalpy sa ating steam is obtained in steam table based from its saturation temperature. Ito namang ating HB sa ating vapor will be taken from the steam table kung saan ang basis naman natin dito will be at temperature T1. Okay, so yan naman ang ating temperature para sa ating HV. Okay, so punta na tayo dito sa ating HL, no? Paano natin makukuha itong enthalpy sa ating liquor, which is HL? This is equal to the CP of our liquor times T1 minus 0 degree Celsius. So again, kapareho lang ng ginawa natin kanina. Now, we're going to identify. CPL is the specific heat of our concentrated product. Okay? And then, yung ating T1 is the temperature maintained inside the evaporator. And again, itong ating 0 degree Celsius is our reference temperature. Okay, so balikan na uli natin yung ating HS, no? Yung ating enthalpy dito sa ating condensate. So, paano natin kukunin yan? Our HS in our condensate is obtained also in steam table. This is also in reference sa saturation temperature, okay? But this time, this will be in a saturated liquid form. Okay, so ang assumption natin dito is that our condensate leaves the evaporator at temperature TS, yung kanyang saturation temperature. If it leaves at temperature lower than the TS, then we need to determine additional sensible heat. Magiging clear sa atin yan kapag ginamit na natin siya sa ating mga calculation sa ating problem, no? So basically, na-cover na natin. Ito yung ating enthalpy balance and na-identify na rin natin kung saan natin makukuha itong mga values ng ating enthalpy dito, no? Kailangan na lang may apply natin yan sa ating problem solving. Now, there are other things na I would like you to take note. One is how to find the area of heat transfer in the calandria. Okay? Well, the basic equation for solving the capacity of single effect evaporation is this formula. We have Q is equal to U A delta T. Okay, so yung delta T natin dito is the difference between the saturation temperature and the temperature that we are maintaining inside our evaporator. So this is actually Q is equal to U A times TS minus T1. Our Q in here is the rate of heat transfer across the tubes. And this is in unit watts. Okay? So, our U here is the overall heat transfer coefficient. And the unit is in watts per meter squared Kelvin. And of course, our A here is our area in square meters. So, alam na natin yung TS and alam na rin natin yung T1. Well, this heat is also equal to our heat mentioned right here, no? So, this is actually equal to our Q, which is equal to UA times TS minus T1. This is also actually equal to S times our latent heat. Okay, so this means that this is equal to S times HS minus H times HS. Okay, so we have to take note of this equation. Okay, gagamitin natin yan. In fact, napakaraming problem na ganito if you are going to look sa mga textbooks. So we're going to use this in the problems that we're going to solve sa mga next videos natin. And then, another na may encounter ninyo is yung performance. Okay? And the performance is actually expressed as the steam economy. So, steam economy is actually equal to feed over the steam. And the typical value of steam economy for a single effect evaporator is close to 1. Okay, so let us take note of that. Alright, so that's basically it for our mass and enthalpy balance sa ating single effect evaporator. So, in our next video, we are going to use itong natutunan natin for enthalpy balance in solving a problem. So, with all of that and more, I will see you in our next video.